Good evening, sir.
Yeah. Good evening, everyone. I hope the screen.
Good evening, sir.
Good
Yeah,
evening,
good
sir.
evening.
Good evening, sir. Sir, what
Good
is
evening.
going today?
Okay. Okay. So in the last class, we completed the chapter gravitation and flotation. Right. We have also done the question answers from that chapter. So definitely today we'll be starting with a new chapter of physics. So in the new chapter, we have work, energy, and power.
Work and energy.
Yeah. And so and energy. Work and energy. Energy. So see, in our common language, when we say about the work, we mean that work can be anything. Means our writing is also work, playing is also work, studying is also work. We do have different work. Okay. When in physics we are doing a work, we mean it as a physical quality. The Good evening, everyone. Am I audible?
Yes, sir.
Okay, so let's continue again. So I was discussing about the work. Whenever we say in our normal, when we say work, so activity which we do in our day-to-day life, the activities like walking, uh, we say work. Say walking also work. Uh, um, yeah. So we say our walking is a work. Is also a work. Hello.
Yes.
Hello. Working class.
Sir, your voice is little
Okay.
bit
So
breaking.
what all different activities we call as work? All walking, picking up of the things, picking up things, moving or pushing objects, all these activities which we are doing in our everyday life, we call this
I
the
shall
work.
work.
But when we talk in physics, yeah,
Yes, sir. Yes, sir.
in physics, what do we define the work as? Since work is a physical quantity, that means it can be measured. So how do we say work?
Your voice
It
is
is,
breaking.
is it?
Yes, sir. In the middle, it's breaking. Your voice is
Okay.
breaking, sir.
Let me check my speed. Just give me 1 minute. I check my speed. Okay, am I audible clearly?
Yes, sir. Yeah.
Okay. So see, we define work to be a physical quantity. So when we say the amount of work, we'll try to define it, but first let's try to understand how we can measure work. So work, it depends, which work we have, it
Sir,
depends
it's
on two factors.
in
Let's try.
Joule.
Yeah, it is measured in Joule. Try to understand what I'm talking with the. Okay.
Yes, sir.
Suppose consider here two cases. Okay. So I have given two people. All right. So there are two people whom I have given. One I have given here a mass of, let's say there are bricks, and suppose there are 1000 bricks over here. This person has to put this 1000 bricks from one place to another, which is located about 100 feet. All right. Let's say to the second person, I have given another task. To him, I have given bricks. Right. Let's see. Given here two tasks. So maybe. All right. So see, we had considered here. I consider here two people. One person to one person, I have given 1000 bricks. To the second person, I have given it 2000 bricks. All right. So both of them, they have to put these bricks. The first person is supposed to
Are
put
you
it to a
sharing your
distance of
screen?
100. Yeah, I'm sharing.
Sir, I can't see the screen.
At the screen. I'm facing today only the network issues. Okay, now it should be visible. Now I think now it should be visible.
Yes, sir.
Okay, so there are two bricks. Here I have 1000 bricks and here I have 2000 bricks. So, and the 2000 bricks, it has to be shifted. No, they have to do the work. So, which one of them do you think will be less work? Where does a person has to do a lesser work, and where does a person has to do greater amount of work? Can you think in which case the person has greater work and in which case the person has to do a smaller work. Now, to understand and solve this problem, you must mechanism to calculate or to be able to find out that how much work the person is doing. All right. Yes. Rohit.
Yes, sir.
Okay. So is this clear?
Yes, sir, it's clear.
Okay. So we need here some mechanism by which we can say we can measure the amount of work that the person has done, and then we can compare that who has done a greater work. All right. There are two people. Let's say, suppose to someone I give a task of bringing some object from top to bottom, and someone I give a task of keeping some object from bottom to top. I must have a measure. I must know that who is doing greater work and who is doing a smaller work.
Sir, your voice is little breaking.
Okay, just give me 5 minutes. In 5 minutes, it will be okay.
Okay.
Yes, sir.
It will be done in 2 minutes. All right.
Yes, sir.
I'm saying नहीं. Okay, just check it. Is it okay now?
Yes,
Yeah,
sir.
is it okay?
Yes, sir.
Okay. So see, we must find a mechanism of measuring the amount of work that a person is doing so that we can compare it. We can say that how much you have done, the amount of work. So
Sir, I'm there.
yeah, what happened?
Nothing.
So see, so the amount of work done is calculated in both the cases. How do we see the amount of work? So we see the effort that the person is putting, that is the force that the person is applying, and the amount of displacement that he is covering. Can I say like this?
Yes, sir.
Okay. So we define this quantity of work done. So the amount of work done, it depends on, I can say it depends on the force that a person is applying, and also it also depends on the displacement that a person is making. Okay.
Sir, displacement. Okay, sir.
Okay. Displacement. So it's the displacement. For example, suppose I will discuss about this. So this work done can be written as the product of
Force.
force and displacement.
Yes, sir.
Okay. So work is defined as the product of force and displacement. All right. So understood this fact that why we calculate the work to be the product of force and displacement. So it is always this product, force times displacement. Now this work equals force multiplied displacement, and hence its SI unit can be obtained. The SI unit of work can be obtained as force is measured in Newton and displacement is measured in meter.
Meters.
So it would be Newton meter, which we also call it as joule. The amount of work done is measured in joule. Now
Joule.
see, okay, here when we are talking of the force, we are especially emphasizing on the force that you are putting to make the displacement. Okay, if you are putting your force in some other direction and your displacement is not over there, so obviously your work done is not be effective. For example, there may be some people who will tend to like they're supporting in the displacement, but they may not be supporting. So consider this situation of pulling a box. So here we keep a box, and suppose you are pulling it by applying some amount of force over there. Okay, so the amount of force you are applying over here, after that it is moving through some displacement here in this direction. So this is the green line, it shows the displacement that it makes. So this is the direction of displacement that has been made, and this is the force. Okay. Now as I can see, the force is not acting in the direction of displacement. It is making some angle with the displacement. Now what I think is a part of this force is being used up to lift this block in the upward direction. Let's see. A part of this force being used in the perpendicular direction to lift this, and a part of this force being used over here to move this along the displacement. So there are two parts of this force. One is the perpendicular one, which is being used to lift it, and the second part of the force, it is acting along the displacement. Do you think that there will be any displacement if the force is acting only along the perpendicular direction, only in the upward direction?
No, sir.
No. So there will not be any displacement along this direction. So that means we can say here the perpendicular component of the force does not contribute to work. Can we say like this?
Yes, sir.
Yes. So we'll see perpendicular component of force the perpendicular component of force does not contribute perpendicular component of force does not contribute to displacement, and therefore I can say that this force is not doing any work.
Yes, sir.
So work done by the perpendicular component is always zero. So therefore I can say work by perpendicular force, work by the perpendicular force is equal to zero. Got it? Work done by this perpendicular component of the force is always zero. There is no work which is done by the component of the force along the displacement. Okay. Only the force which is acting along the displacement contributes towards the force. So now we'll redefine the amount of work done here. Okay. So how we'll say this? We'll say now the work as it is, we'll say work it is the product of
Force and displacement.
no, not like that. It is the product of displacement the force acting in the direction of displacement. Acting in the direction of displacement. So the force must act in the direction of displacement, then only we say that some amount of work is done. It's like if someone is not applying the force in the direction of displacement, so we will say that that person is not contributing towards the displacement. Yeah, there can be cases where a person may be opposing the displacement. For example, consider this situation. Okay, so suppose here you are riding a bicycle, all right, and you are trying to move your bicycle in the forward direction. So I don't know really how to make a bicycle. I just try it. So here you have a bicycle. This is your seat and this is a forward direction, all right. And here you have this wheel arrangements. So suppose you are moving this bicycle along this direction and there is some of your friend who is applying a backward force on it. They are pushing you backward. They are pulling you backward. So can I say that they are doing some work?
Yes, sir.
But are they contributing towards your displacement?
No, sir.
Then how can we say that they are doing some work? See,
Sir,
your
they're applying
bicycle, your bicycle is moving like this. You yourself is applying a force in the forward direction. So this is the force you are applying in the forward direction, whereas your friend is trying to pull you backward. Okay. So does he contribute to your displacement? Does his force increases your displacement?
No, sir, it decreases. No, because he's pulling
Yeah,
backwards.
it decreases. Yes. So the force applied by him decreases the displacement, and we can say that the applied force which the work done by my friend is the negative work done. He is not helping me out. Okay. Whatever work I could have done, he is not letting me do that work. Okay. So the work done by this person is negative. Got it?
Yes.
So there can be a positive work done, there can be a negative work done, or there can be even a zero work done.
Oh, yes.
Okay. So this we discuss here as nature of work done. So if you discuss the nature of work done, it can be a positive work, a negative work, or a zero work. So your nature of work, it can be discussed as positive, negative, or
Or
zero. When it is a positive work done, if the
sir, it's
force,
acting in the direction of displacement.
yeah, if force is acting in the direction of displacement, then we have a positive work done. If the force is acting in a direction
Acting in the
opposite to
opposite
the displacement,
direction, displacement negative.
then it's negative. And if the force is perpendicular to displacement, then there is a zero work done. Or it can also be if he is applying the force, but there is no displacement. So Jitendra,
Yes, sir.
can I say that he has done some work? If he is applying some force, but there is no displacement. So can I say that he has done the work?
No, sir.
No, sir.
Okay, suppose I tell you, please push this wall and keep it aside. So you try all your efforts, but you are not able to move the wall.
Yes,
So
sir.
you got tired also, but the wall has not moved. Or if I tell you to move a heavy stone, so you try all your efforts, but you are not able to move it. So in that case, you have put your efforts, but you haven't done any work. My work is not done. Okay. So I will say here that work done is zero as the displacement is zero. Got it? Okay. What will be the work done? Suppose if you throw a stone in the vertically upward direction and the stone returns back to your hand. So what will be the work done in that case?
Sir, nothing, no.
Nothing.
No, sir. Positive
Sir, displacement is 0.
0.
Yeah, the displacement is 0. So what will be the work done?
0, sir.
0, right? So when the displacement is 0, that means you haven't done any work. All right. Okay. Suppose there is some displacement and someone is there who is just acting as if he is applying the force, but he's not applying a force in the direction. So can I say that he has done some work? So no. Okay. So considering all these aspects, we redefine the formula of the work done. We rewrite the formula of work done like this. So we can rewrite the formula of work done to be, I can write work to be equal to Fs cos theta. Okay. Now what is this theta? Theta is, we take this theta as angle between force and displacement. So the angle between force and displacement is the angle theta, and cos theta, so you say cos or cosine, it is a trigonometric ratio. It is a
Yes.
trigonometric ratio defined to be the ratio of base and hypotenuse in a right angle triangle. So in a right angle triangle, it is a trigonometric ratio. Okay. So for this use, I give certain values which you may remember. For example, cos of 0 degree is equal to 1. We say cos of 60 degree is 1 by 2. Cos of 30 degree is root 3 over 2. And cos of 45 degree is 1 over root 2. Got it? Then cos of 90 degree is 0. So you don't really need to remember all of them since you haven't studied about the trigonometric ratios. So wherever the values involved, you must be given these trigonometric ratio values. Okay. All right. So what all values will mostly be used is like, you must remember cos of 90 degree. Okay.
And yes, sir.
And cos of 0 degree, which is 1. Cos of
1,
90 degree is 0.
0.
Okay. Cos 60 degree is used sometimes, which you will be given in the question. All right. So Sharwan,
Yes, sir.
Sharwan.
Yes, sir.
Okay. Will you try to do one question?
Okay, sir.
Okay. So all of you try this question here. So a man pulls mass of 10 kilogram by applying a force of 20 Newton at an angle of 60 degree. To the horizontal. To the horizontal. Find the work done by him if he pulls it through 50 meter. Okay. So what will be your answer? Find out your answer. Find out the answer for this question.
Sir,
Yes.
angle of 60 degrees means do we use cos 60 degrees here?
Yes, yes. You have to use cos 60 degree.
60 degrees into the work done, right? Like half
Yeah.
into work done.
Yes, you will use cos 60 degree, which is 1 over. To quickly do this, then we'll move to the next subtopic.
So can you explain this topic once more?
Okay. So see, the work done by a body, it depends on force and displacement. All right. This topic you had seen over here in the first page. By considering this example, we consider that the amount of work done, it depends on the force or the effort that you are putting it and the amount of displacement that you are making. For example, if this person has to move 1000 bricks, so how much force does he need to apply? This person has to move 2000 bricks, so he has to apply a greater amount of force, right? But this person has to apply a smaller amount of force as compared with this one. But the first person has to make a displacement of 100 meter, whereas the second person has to make a displacement of 50 meter only. So the amount of work done will depend on both the things. It will depend on the force that you are applying. Also, it will depend on the displacement that is made. Okay. It depends on the displacement as well as it depends on the force. Got it? So from this, we got the formula of work to be equal to force multiplied displacement. Understood this part?
Yes, sir.
Okay. Now in the second case here, what if I am applying a force at a certain angle to the displacement? Suppose if I see a person pulling a briefcase. Okay. So when a person pulls a briefcase, he applies a force at a certain angle and then he pulls it along the horizontal. So in this case, what happens? All the force is not being used in the displacement. A part of his force is being used in lifting up this a little bit upward, and only a small amount of force is being used in moving it through a horizontal displacement. All right.
Yes, sir.
So we discussed that this vertical component or the vertical part of the force which we see here, this vertical part of the force is not contributing towards the displacement. For example, if I keep a block over here and I just apply a force like this, so will there be any displacement over here?
No, sir.
No, there isn't going to be any displacement along the horizon. So I can say that this vertical amount of force is not contributing anything towards the displacement. So we don't consider that. And now we also need to consider the angle between force and displacement for the work to be done. Therefore, we redefine the formula of the work done to be Fs cos theta. Okay. So here we have rewritten the definition of work as force multiply by displacement multiply by cos theta, where theta is the angle between the two. So different values of cos I have given to you. Cos 0 degree is 1, cos 30 degree is root 3 over 2, cos 60 degree is 1 by 2, cos of 45 degree is 1 over root 2, and cos of 90 degree is 0.
So it
Okay.
means to find the work, we have to multiply the force into the displacement into the angle, like
Yeah,
one
into
one.
cos of the angle, yes,
Yes.
cos of 60 degree.
Okay.
Okay, so cos of 60 degree is 1 by 2.
Okay, sir.
Sir, then what about mass?
Nothing. You don't have to do anything with the mass. It's only the force that you are applying,
Sir, I
the
got
displacement,
500
the
NF.
displacement that is making, right? So your answer over here, it will be
500 joules, sir, I got.
okay. So you'll get your work done to be equal to, I'll write work done here. as Fs cos 60 degree cos theta, which will be force is 20 multiplied with displacement, which is 50 multiplied with cos
Half.
60, which is 1 by 2. So if you multiply, you get is 500 joule of the work done.
Sir, I got it.
Got it? Okay. Now let's do one more question
Sir,
here.
1 second.
Sir, they'll mention the cos theta of 60 degrees, right? If they give it in a question.
Yeah, they will mention. Okay, you just now need to know that cos 90 is 0.
0 and cos 1 is cos
Cos
0.
0 is 1.
Yes, sir.
Okay, so we'll do some questions from NCRT here. I think there is some question in NCRT. So we'll see work energy NCRT. Okay, see this question. A force of 5 Newton acting on an object. The object is displaced through 2 meter in the direction of force. If the force acts on the object all through the displacement, then the work done will be given by 5 times 2. Okay, can you
Then-
obtain for this one? When the angle is not given, then you consider it to be
F into S only.
F into S, or think of the situation accordingly. See this. Solve this. You have a
Sir,
force of 7
diagram
Newton.
doesn't- Sir,
Yeah? Yes?
diagram doesn't need to be drawn, right?
No, it doesn't need to be drawn. If you want to draw, you can. Otherwise, it doesn't need. So you have a force of 7 Newton act on an object. The displacement is say 8 meter in the direction of the force. So what will be the work done?
Positive.
Positive. And how much?
Sir, 54.
56.
Sorry, sir. 56. Sorry.
Okay. So here the work done is 56 joule.
Joule.
We obtain here the work done to be equal to force multiplied displacement, which is 7 multiply 8, which is 56. You can see that they are in the same direction. So theta will be 0. You can use cos 0, which is just 1. However, no need to use 1.
Work done in this case is in the
Direction of displacement.
displacement, right?
Yeah, in the direction of displacement, so you can directly obtain it. All right. Okay, now see this one. Okay, okay, we'll see this question. Example 11.2. See. A porter lifts a luggage of 15 kilogram from the ground and puts it on his head 1.5 meter above the ground. So calculate the work done by him on the luggage.
So, sir, mass is given,
Mhm.
displacement is given. So first we can do weight is mass into gravitation, m into g to find the force. Right, sir?
Yes. Yes. So you'll find out the force. Since he's doing the work against the gravity, So he needs to apply an amount of force equal to the gravitational.
This displacement will be 0, right?
No, displacement is 1.5. He just picking up from the ground and keeping it on his head. Okay, so the displacement is 1.5 meters. Can you obtain the
Yes,
answer?
sir. We can.
Yeah. Sampath, Shravan, 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 are you there? Otherwise,
Yes,
we'll
sir, yes,
publish
sir.
your name in the Times of India.
Sir, can you
Shravan?
hear me? Sir, can you hear me?
Yes. Yes,
Yes,
you're audible. So, Shravan, can you solve this?
yes, sir, I'll do it.
Okay.
Sir, I found the answer.
Okay. So, first of all, we need to find out the force. Shravan?
Yes.
Okay, Shravan, pay attention. The amount of force is not given since, see, the gravity is attracting this and applying a force equal to its weight, which is equal to
Gravity.
15 times of 9.8. Okay. So, this will be the work. Yes. So, this should be the force. Now, the coolie must also apply the same amount of force. The force applied by the coolie should be equal to 15 times of 9.8.
Sir,
Okay.
147.
How much? 140?
Newton.
Okay, so you are getting 147 Newton as the force. The displacement is 1.5. So you can
1 point,
obtain the work done to be,
it is F into S.
yeah,
So
147.
1.5, which is 220.5 Newton meter or joule.
Okay, so 220.5 Newton meter or joule.
Sir, how did he get 147 Newton?
This is mass multiply acceleration due to gravity. M multiply G, which is the weight. Okay. So whenever the work is done against the gravity, then you use the weight as the force. Since weight and force, they are the same. Okay, just one small thing again. Let's try to find out the work done by the sun in moving the earth around it.
Sir, work done by moving the sun around the earth.
Work done by sun in moving the earth around it. Okay. So let's see how much work is done by the sun. In moving the earth around it. Okay. So as we know, the earth moves in an elliptical orbit over here. So currently we can consider it to be a circular orbit also. So let's take our sun and the earth and let's make them move in circular orbits. All right. So we have our earth which is moving around the sun. As we know that sun needs to apply a force of gravity. All right, sun applies the force of gravity. Okay. So sun applies the force of gravity on on the earth, and this gravitational force, it acts along the line joining the two masses. So the force acts towards the center. I can say that the sun is providing the centripetal force by attracting the earth towards itself. So am I correct? This will be the force of gravity with which the sun is attracting the earth. And in the circular motion, we had studied that any object which moves in a circle, its displacement or its velocity is
Is
along the tangent.
sir.
Yes?
Yes,
So
sir.
the
Yes, sir.
velocity or the displacement is along the tangent. So this is the direction of velocity, or you can say this is also the direction of displacement. Okay. So what is the angle between the force and displacement over here? Isn't it 90 degree?
Yes, sir. So
Okay.
cos of 90 degree is
Hmm. We had
uh,
done cos of
root
90
3 by
degree
4.
is
Root
0.
3 by 4. Right, sir?
Cos of 90 degree is
Sir
0.
is 0.
Okay.
Uh, 0, 0.
Okay. So work done will be given as force multiplied with displacement multiplied with cos 90.
So
So
work
this,
will be done 0 only, no?
yeah, so the work done is 0. Anything multiplied with 0 is 0. So I can
And
say,
displacement is acting perpendicular, right, sir?
which one?
Like the force is acting perpendicular to the
Yeah.
direction of. So it will be
Yes.
0.
Yes, the force is acting perpendicular to the direction of displacement. Therefore, the work done is 0. All right. We can also consider here the case of a porter. Okay. Let's consider the case of a porter who is lifting your luggage from one place to another. All right. So the porter lifts your luggage, brings it from one place to another. Let's say I write here work done by porter. Okay. So what is the work done by the porter? Let's say consider here the porter carrying your luggage from one place to another. So suppose the porter starts from here. Uh, he is carrying your luggage on his head from this point. He travels a certain distance over here. Okay. And here is the luggage. Okay. So in this way, he is doing work against the two forces. What are the two forces we are discussing? First of all, he is doing some work against the gravity. The gravity is pulling this luggage in the downward direction. So he is constantly applying a force in the upward direction. All right. So, however, the luggage is not making any displacement. The luggage is at the same point. It's not making a displacement along the vertical or in the direction of gravity. So we say that there is no work done by the gravity, or we can say he is not doing any work against the gravity. Got it? So work done, if I say there is no work against gravity or zero work done against gravity. Got it? But if I say, yeah, against the friction, against the frictional force, he is walking. So while walking, he is doing some work to overcome the frictional forces, and therefore he has made some displacement against the friction. So definitely he has done some work against the friction. Okay. So here work is done against friction, but there isn't any work done against the gravity. So got this concept of the porter? Yes. So with this, we end up this class for today from work. In the
So
next
can you
class, we'll
explain
continue.
again, please?
See, okay, suppose the porter lifts your luggage from here, keeps it on his head. Then he moves through a displacement S,
Mm.
and then again keeps it down over here, your luggage.
Yes.
So in this way, the total displacement along the vertical, or you can say against the gravity, he is not doing any work. As against the gravity, the displacement is 0. The gravity is acting in the downward direction. All right.
Yes, sir.
So in this vertical direction, he is not doing any work. Or you can say his displacement along the horizontal is making an angle of 90 degree with the gravity. You can say like this
Yes.
also. Okay. So there is no work done against gravity. But he is constantly spending his power to overcome the friction.
Yes.
Right? So to overcome friction, he is spending his power. He is doing some work against the friction. So a work is done against the friction, against the frictional force of the ground. He is doing some work and he is lifting the luggage from one place to another. Got it?
Okay,
Yes,
sir.
sir.
Sir, can you just share the notes?
Okay. All right. I'll share it.
Okay, sir.
Do you want to share it to Wise app
Yes,
or in the group?
so why is that?
Okay. Okay. All right. Bye everyone. See you.
Bye,
So
sir.
thanks.